And this is today's agenda. So first of all, I will introduce how today's PLC agenda. Okay, I will introduce how the DIATwin works when we have doing with the PLC aspect. Okay, and next is we have to do some modeling for connecting to our PLC. Okay, and next is what corresponding setting we will do in the DIATwin Designer AX. And for DIATwin Designer AX, they already have the virtual and physical PLC inside, and both of them are able to control the virtual machine in DIATwin. So today we'll focus on the virtual one, but we also have the actual slides operation in our slides today. But we will not introduce, we will not ask everyone to manipulate this process today. And finally is the connectivity parameters for communication is to have to collaborate with DIATwin Designer. So maybe we'll also have some connectivity settings so that we can connect the virtual machine to DIA Designer AX. Okay, so that's today's agenda. Okay, and first of all is the introduction. I will go really fast. So by the stages we developed the machine, we have three kind of stage. Okay, concept design, pre-sale, and virtual machine and commissioning. Okay, so pre-sale, virtual machine, commissioning. And for what we are doing with PLC is for the machine maker, and most of them they will be interested in how to reduce the development cost. Okay, so we will use application mostly in this stage. Okay, so we can use the PLC to control the actual machine and also control the virtual machine at one by one. So you can make sure that when you are programming your ST code, your later code, it will be faster. Okay, so it's at this stage. So this is the scenario that we can use in DIATwin on PLC is when you are using the physical PLC. Okay, so you can see at the left-hand side is every brand like Delta's, Mitsubishi's, Omron's, and even some of the brands is not mentioned. What we are caring about is if this PLC has support this kind of communication protocols like EIP, OPC, UA, Modbus, and they are able to be communicated with our DIATwin. Okay, so by user they will see DIATwin software in their own MB or PC, and also the PLC programming UIs in the same screen, so they can just do commissioning like this. Okay, so here's the example for it. So you can see at the left-hand side is the physical PLC settings, which use the DIATwin, the DIA Designer AX, and at the right-hand side we can use it for control the virtual machine. Okay, and next scenario is we use the virtual PLC and virtual machine, and we can see everything is virtual. We don't need to connect the actual PLC to your own PC or MB. We just use the virtual PLC. And why we can done this is because the AX series is already have the coded simulator in their core, so we can able to use the coded simulator to replace the actual PLC. So you can see the PLC is virtual, but we also can use the same programming software, and we can also have the virtual HMI to design your process interface. And also the communication between this virtual PLC and DIATwin is also use the same protocol. Okay, and this is the also example. You can see it's actually very alike, but we just changed the controller of it. One is the actual controller, and another is the virtual controller. Okay, so what do we need to set in our DIATwin to make the model can communicate with PLC? Okay, you can see this is a structure of it. So in yesterday's training, we do have using some like local programming or modeling way, and also you already learn how to connect the I/O wires, right? And but for the PLC cases, we have to distinguish what kind of component you are going to control. Okay, we can set like an easy way to distinguish it is at the top hand side is the analog signal. So if like you are using XYZ cable or not just only simple I/O signal, and you can use you have to model this kind of component singly, okay, separately. And in our DIATwin, where we already have sensors, conveyor cameras, the kinds of example model, and all of this model will be controlled by a simple digital input or digital output, and this so will be also a single component. So what does this mean? Okay, you can see in our layout, okay, we don't make the XYZ module also with this sensor. You can see there are different components. Okay, so sensor have sensors component, and XYZ module have XYZ modules component. That is because the signal we want to communicate with our PLC are different. One is analog and one is only simple I/O. Okay, so you can see there are many lists, and you can connect all the wires to one center, which we call the PLC component in DIATwin. Okay, so once we have done this kind of process, you can see only discrete XYZ analog data component and digital data component, and this component have different controller. We have to set it up, okay, and they will be connect to the top controller in digital world. And next, we will ask this top controller to use the communication protocol such as EIP to our AX PLC. Okay, so you can see as a controller setting, we can check it if it's right or not. Okay, in our example, it's already set it. So like we are talking about the XYZ module right here, is we are sending the analog signal, right? And by this, we will use the signal action behavior. You can see like this. Okay, so maybe you can just try to open up your project today. Is the DIATwin PLC example 1.2, and okay, find out this component. Okay, you have to click on in modeling. Modeling, and just double click this module, and you will find in the first layer of behavior, you can find signal action behavior. Okay. Okay. Yeah, just double click. I'll do it again. I just click on the floor, double click the module, then you can see the component will be auto return to what I want. And next, I just clicked the signal action behavior. Okay. Yeah, also today's same link. Yesterday's same link. Yeah. And you have to follow with the chapter 6. It's at this session we are teaching the PLC communication. So you have to log in the FTP sharing link and download the corresponding course material. Okay. Is it trying to catch up the progress right now? Okay, and you can also just expand each axis. Okay, like we also, like as yesterday's lecture, we have link X, link Y, and these two link. Okay, and you are also able to control the link like this. Y, and also Z. Okay. So maybe we can try this first. Okay. Yeah. Let me right here. We got the FTP server link, and here is PLC. Yeah, at the 6 capture PLC, you have to download these three file. Okay. Okay, sorry, please wait a moment. And if okay, and I'm back right now. So you can see what is this. Okay, maybe you can also switch to the signal action behavior right here. Okay, so you can see the signal action right here. Okay, what the signal action will describe is, at the left hand side is the address of it. Okay, maybe you can also follow with the page. This page, okay, page 20. It's later, sorry. I think I will just go through it. Okay, will be more better. Okay, so as I have mentioned, is we have to decrease different kind of component to different component. Like XY table already have using the signal action behavior, right? And this is for analog. And but if you click on the sensor, also double click, okay? Double click. You can also see here's the behavior, like using the sensor behavior, only sensor. You can see these two are different components. We're not using the same component for PLC programming. Okay, and next, when you click on the root node of this component, you can see at the down right hand side, here is the where you are using DIATwin device controller. Okay, so basically this will be automated selected. Okay, but if you are using SOE module right here, the controller is DIATwin signal controller. Mostly you have to use manually select to set it up. Okay. But in our example, we already set it up for you. Okay, so you just have to remember, for the analog signal, we use DIATwin signal action controller. For digital input, we use DIATwin device controller for it. And to create the corresponding behavior to connect the relation with the emitter receiver and the link or device. Okay, so first of all, I will just go through it again. So that is our purpose. What this signal action controller and device controller will do is to pass the receiver data or emitter data to the specific link device to make it have the behavior of the electrical component. Okay, or maybe have the behavior of a movable XYZ table. And by realizing this thing, we have to create the behavior for it. Like for XY table, we have to create signal action behavior, or like sensor, we have to create the optical sensor behavior. And most of this behavior in DIATwin is right here. You can see in modeling, you can click on the behaviors. Okay, you can see most of these general behaviors. Okay, I will do it again. Modeling behavior. You can look up this table. You can see here's nozzle and conveyor, air cylinder, everything will be at this place. Like I just use behavior and add air cylinder. It will be a new air cylinder. This is the same way as we use the right click. Okay, it's the same way. So both of it is okay. Just click on the node and just click behaviors. And what I said is like a sensor, actuator, general, these three kind of specification, we use the device controller for it, and we have to create the corresponding behavior. And like yesterday's training, we also have to connect this receiver emitter signal to our top controller, which in our model, is like we also click program again. Okay, maybe we can check out this AS332T-A is the PLC device in our virtual world, which is also the device that we want to communicate with the actual PLC. So we have to click this first. Okay, and second, maybe we can click on the X-ray module and find a sensor. Okay, we can check. So there's a relationship right here is like the PLC will send emitter XYZ command to the XYZ module, receiver XYZ command. Okay, and also for this XYZ module, they have encoder value or the position value. They can return it back to our PLC. And next is the sensor will send signal to the top controller, right? The PLC. And also if the PLC have some input, maybe emitter for they want to control a conveyor is also possible. Just need to wire a new line to our conveyor, maybe like this. Okay. Yeah, like this. Okay, maybe do like this. Okay, but you don't need to operate it right now. Just have a quick overview of it. Okay. So that is the concept. Okay, we do use behavior to control the device node or link node in our modeling tree, and we use controller, which is the core to realize this behavior. And finally, the controller will use emitter receiver signal, which is I had mentioned in this line, to have the signal exchanging with the I/O controller, right, which is the PLC in virtual world. Okay, so how do I need to select the device controller? Is right here. Maybe you can try this right now. Okay, you just select modeling tab, select just double click. Okay, the sensor, and select the root node of the component, and you can find here's the settings. Okay, so maybe everyone can try. Can you help me to do this? Is I just click a sensor. Okay. In modeling. Okay, click a sensor. Double click, and use link origin sensor, and help us to find if your list already set to the controller is already set to DIATwin device controller or not. Okay, so I'll stop at this page. So we just need to check it out. Okay, we don't need to have some settings right now. So just check out. We do know for digital component we use this controller. Okay, and next, okay, we can see. Oh yeah, this is some modeling technique. Okay, so like what we need to do is to also here is the optical sensor behavior right here. Maybe we can use right click on the behavior and create sensor behavior and select the device. So this process is also like yesterday, right? Yesterday we already teach everyone how to use like general friend and our source behavior to generate something. So this is the same way. So like in the our sensor again. Okay. So like maybe I can delete it. Okay, delete it. Okay, it's okay. So you can see when I need to add the behavior. Okay, I just right click. Okay, and find sensor. So here's the optical sensor behavior right here. So I add it back. Okay, and you can see here is a sensor already be built. It's distance sensor 2 right here. Also, it's at this position. You can see, yeah. You can see the X direction is the detecting direction, right? So you also already be set it. And also, we can use like digital output to setting up the relation with the emitter device. Okay, so we just click it back. So I just deleted it and add it back. Okay, so to tell us how we use behavior settings. Okay. And next, so that is a kind of a digital signal, like that's how the modeling works. And another is the analog signal, like XYZ table. We have to control the axis value, right? So that is also another one. So also you can help me to click on the table again, double click. So you also click on the root node of the XYZ module. You can see here is a DIATwin signal action controller. Okay, so please help me to check it out. Okay, so also this will be a kind of behavior that we need to set it up. Okay, and here is the already have a video for it. Okay, so you can see we also have to add behavior. Okay, add signal action behavior like this. You don't need to do this because that's alright. Just watch it. And we will use this also like selecting the device, selecting the emitter receiver. So like this, we have already emitter receiver. We select the link device, which is the XYZ value we want to control. And at the right-hand side is the resolution. Maybe you have to translate the pulse number to actual distance. Okay, this will be a translation for it. Yeah, by this way, we just set it up a relation between how the emitter receiver signal and set the command to the link device. Okay. Okay, and here's the explanation of this UI. You can see, okay, the first one and sixth one is emitter receiver. Okay, one at the top hand side is input, at the down hand side is output. So you can see we use setting emitter receiver address. We set the corresponding link device, okay, XYZ, or maybe position of the XYZ. And the third one is the function call, mostly because we use input, right? So this device is to receive the signal from our PLC, right? So this will be set position to link motor X. And at the other hand is this component wants to send the incoherent signal back to our PLC. So we have to get value and get the position sensor X value to our emitter, and the emitter will emit signal to PLC. So that is the structure of it. Okay, and here's the resolution. Just maybe some proportional converting. Yeah. Okay, and here we already described is because we want our device to send signal to our PLC in virtual world, right? So we do need the in program also signal. Okay, you can see here we already have connect all this signal to PLC. Okay, so maybe we can just choose 3 of it, like choosing the PLC and the XYZ module first. Okay, you can see the relation right here. There will be a cross. Okay, 3 emitter signal want to send their encoder return. Right, sorry here. Okay, to our PLC, and our PLC have 3 commands want to control the XYZ module. So we have 3 lines here and 3 lines here. Okay, you can just try maybe to delete it and add it back. It's also okay. Okay. So that is connection. We have to create the communication inside DIATwin to make our PLC in virtual world able to control other components. Okay. So yeah, that is the structure of it. And we already have every signal already right here. Okay. So we use IO table to send emitter receiver, and this emitter receiver typically we use for digital input output, but for signal action behavior it's also fine to transmit analog signal. Okay, and next is how the virtual component in DIATwin able to construct the communication with our AX. Okay, so here's the point. Okay, we have to use another controller. We call it DIATwin IO controller. Okay, what this DIO controller do is there will be a bridge between the PLC in virtual component and also the PLC in actual one. Okay, and we also got the function is IO controller have a manual mode is able to control the IO by the interface. So even the connection is not constructed, it's also able to manually testing your signal. And we will do this exercise later. Okay, so by this we will use the connectivity behavior. Okay, and this behavior will create the exchange table because we, by using PLC we use the EIP protocol, and which will be constructed by the EDS file. So we have to export the EDS file first, and also when you are using EIP, you'll be able to have the data exchange between IO controller and the physical or virtual PLC in DIATwin in DIA Designer AX. Okay, like this. So here is also a little quick setting. So what is the component in this example? We can also double click the select PLC component and find out is the controller is DIATwin IO controller or not. Okay, so right here, back to our UIs in our software, you can see here is a PLC component. Double click. Okay, switch to modeling tab. Okay, modeling tab. Double click the component. Also select the root node. Okay, it's the same way with everything. It's the same way. Okay, so you can see here's DIATwin IO controller. Okay, so you can see the component have the same structure to distribute to point out what controller is using when I use one component. So that is why we have to distinguish like analog signal or digital signal, because this component cannot be combined in one component because they have different controller have to use. You mean why do we have to distinguish different components? Yeah, because each component we did have like setting the behavior, right? The behavior have the corresponding controller, but one component only can have one kind of controller. They cannot combine to each other. I cannot add two controllers in one component. There will be some conflict of it. So that is because our communication structure, we have to add one controller in one component. So by this way, we already restrict that we cannot use like hybrid mode to send digital or analog signal simultaneously in one component, because the controller cannot do this. Yeah, that is because the modeling, this is modeling restriction. Yeah. So like this in this page. Oh, sorry, I think this page will be better. Yeah, this page. So I say analog and digital cannot combine because they have used different controller. So I cannot have a component that is excitable with sensor. Okay, we cannot do this kind of modeling. We have to set excitable for one component and set sensor to another component. We can just to make it separately. Yeah. 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 Oh, I got it. That is because you can seek this one as a speaking tube. I just tell you A to Daniel, and Daniel will tell him A again. So this is just a virtual PLC to represent the actual PLC. So just like speaking tube, I just tell you something and you will tell him something. But actually the signal are the same. Okay. But we use this kind of way to create it. Yeah. Functional. Sorry, what you mean? What the function or? Oh, I'll introduce it later. Yeah. For PLC, will be recommend to use EIP because it is original suggestion protocol for PLC. Yeah, will be have the better support. Yeah. Yeah. Yes. So as we mentioned in our scenarios, we can have different brands: Deltas, Mitsubishi, Omron, Hiens. Just what depends is supported or not is if they have support this protocol. Okay. Yeah. Okay, and I will go through quickly. Okay, so back to our this page. Okay, we select when we check out the I/O controller. Okay, so this is not at signalization. This is at the I/O controller. Okay, so you can see what we have done is to add the connectivity behavior and to check out what signal you want to transmit to the actual PLC, like this. Yeah, so I think I said this is a speaking tube, right? So I have to tell what signal I want to speak to our actual PLC. So you can see the receiver signal, and at the left-hand side is the PLC EDS file configure signal. Okay, and we'll export the exchange table to as a EDS file. So next, you can see the EDS file will describe the relation between our virtual emitter receiver signal and the EDS name, which will be needed in actual PLC. Also, so back to our operation. So next, you can try clicking on this one. Okay, so Luno is PLC, AS332 is PLC, and click on connectivity. And here will be a pop-up window right here. Okay, so here will be, you can see there's a exchange table. Okay, so how do we operate it? Is first we have to check out the communication mode. Yeah, if I switch to something, this table will disappear. Okay. And next, select the PLC, because this PLC is what I want to connect with the actual PLC. Okay. And I just press refresh. So I can find, you can see here is already built up a lot of emitter receiver devices in this component. So when I press refresh, it will help me to find it out. Okay, and like this receiver link FB is already be configured by, we use the IO connecting, right? So we do know we have this DI. So I just click it on, select it like this. Okay, and it's also selected like this. Okay, just select, okay. And next, I will press add. Okay. Okay, maybe everyone can help me to stop at this page. Because you in today's training, you have to also export your own EDS file for the PLC communication. So please stop at this page. And finally, you have to do this. Okay, sorry, one more thing. The data size. Okay, we have to select the DINT, DINT. This is the data format that we will use in today's training today. Okay, just for the data format. Okay, we stop at this page. So just select the IO name, which is not the default name. Okay, so just with the RECB and also with IA.MKT for emitter, you can just select it and press add and select the data size. Okay, I'll check it out. And next we have to use the apply mapping relationship. Just push this button. By pushing it, when you save your project, and the table will be saved. Okay, if you don't press this one, next time you open your project, the table will be clear. Okay, so you have to press apply. And next, you will make sure it's the int. Okay, you will press the export EDS file, and here there will be a saving file table. Maybe I'll just save it in desktop, and maybe there's a EDS. Oh, I just deleted this too. That's all right. I just deleted it. Can delete. Okay. So maybe I will save an example file. Just everything you can rename it. It's fine. Maybe I will like test. November 28, maybe like this, and press save. Okay, so just save in any place you want in your local PC. Okay, export EDS file and save this file at everywhere you want. Okay, so you can see here will be a file right here. Okay, just export it. So maybe when I back to our Windows file manager, you can see here is a EDS file. Okay, I'll start by this page. Please help me to export the EDS file.
Yeah, this is have to build it, but only one has program. Another is just like stick cube, like the stick cube. So then you A, then you tell A, right? We don't need to have any program at the virtual PLC at this scenario. Yeah, but like even when we are in the pre-sale stage, like yesterday, we do have a PLC, right? And when the program is verified, we can delete the program, but reuse the I/O relationship and just add this PLC connectivity behavior and make every signal transmit to the actual PLC. So that is like a transformer for when your program is in virtual world first, and you can just translate it or just import it to the actual PLC. That's it. So we didn't have a PLC device in virtual world, but it depends on what work you want this PLC to do. You just need it to do some local program, but also we can use component to transmit signals to the actual PLC. But they will be different modeling way. Have to configure some modeling. That's all right. We will have this and we can update it.
Okay, so next is okay. So once it is configured, this is the explanation of each item. So maybe you can just read it later. Okay, so the main point is we use this to build it up an exchange table. We can exchange the receiver emitter signal in DIATwin to the EDS item in AX PLC, in the actual PLC. Okay, and here's another example. Okay, we just click. And we can use, like I mentioned, we can use this for manual control. Okay, so when we switch another tab to the control panel and you start simulation, you can see here will be a table pop up like this. Okay, and when you, okay, so like this, I want to change the value of the x-axis. You can write data right here. There will be times by 1,000 because 1,000 plus is 1 millimeter in our configuration. So maybe you just press like 10,000. You can see it will be 10 millimeter when I'm moving the x-axis. Okay, maybe you can try this. Okay, so I'll demo it again. So in our program, we already have the PLC window and also our program, right? And first we switch to the control panel. Okay, and we start simulation. So here will be a table pop up. Okay, if there is anyone doesn't pop up this window, please tell me. Okay, and next you can just like adding some data, like 10,000. Right. So you can see the x-axis will move. Okay, I'll do it again. 0, or maybe like 50,000, or 500,000, like this. And also you can see here we will have the limit sensor, right? You can follow like receiver link X min limit, receiver link X max limit, receiver link X origin limit. Okay, so the min is 0 millimeter, max is 550 millimeter, and origin is 30 millimeter. You can just try to see there will be the corresponding signal pop up when we control this one. Like when I want to move to the max signal, we use 550,000. Okay, right. You can see here the max limit will have a output right here, because you can see in our model, here's we did trigger the signal right here. Okay, we did trigger a signal, so the signal will use the table, send it back to our receiver, so the receiver will return 1. Okay, like we use like 30,000. You can see the origin sensor will pop up 1 and the max sensor will be 0, and that is because when I move into this place, you can see the x-axis will trigger the origin sensor. Okay, maybe let's take a practice of it. This table will pop up when you start simulation, so please make sure you have to start simulation first.
来的那个 server。啊。
And so this is the manual way we can control it. Okay, and also when you control it, you can like we click on the x-axis, like link X. You can see here is also the value right here. Okay, like here is 30 millimeter. So when we also change the value right here, or maybe 100,000, you can see here will be 100. Okay. So you can also use this to examine the actual value of the x-axis. It will be controlled by this PLC communication connectivity. Okay. Okay, and next, okay, we'll go into switch to another program. Okay, we'll use the DI Designer AX. And first of all, because we will create a virtual PLC in our PC. So we have to set up the virtual PLC configuration, and there will be 2 steps for environment setting up. Okay, first is we have to install a Microsoft lookup adapter in Windows. So at this step, we'll go really slow. So please make sure every step will be followed. Okay, first, right here. Okay, you just type device, you can follow it right here first. Okay, device manager first. Okay. Okay. At this section, we have to add a adapter for our virtual PLC. So that will be the internet will be created by creating this adapter. So first, you just use search and add device manager. Okay, and next you just click the device name, your computer name, and click action here. Okay, add legacy hardware. Okay, the description is already written in our slide, so you can also follow the step in our slide. Okay, action, add legacy hardware. Okay, and just press next. Okay, and click install hardware that I manually select from a list. Okay, and click next. Okay, this is the first page. Okay, you can just follow up this step right here. Okay, and if you still need some time, please tell me or raise your hand. Okay, device manager. Install the hardware that manually select. Okay, and you will be at this page. Okay. Okay, next. If you doesn't follow up, you can just follow the instruction in our slide. So it also describe everything. Okay. And next we'll click on the internet adapter. So to find out network adapter. Yeah, and click next. So at the model list, they will at the brand, manufacturer, you have to select Microsoft right here. In the manufacturer box, check Microsoft. And at the right-hand side, there will be a Microsoft KN test lookup adapter. Okay, right here. Okay, did you find it out? Okay. Microsoft, and we have to add a adapter for virtual PLC. Okay, right here, and click next. Okay, and just click every next, and this will be done. Okay, and finish. Okay. And if you have done this process, you can go to network connections. Okay, you can just use network connection in our search. Right here, you'll find here already. Here will be a KM test adapter right here. Okay, you are accurate too. Okay, here will be a KM test lookup adapter in your internet connection settings. The main problem is the IO component. That is fine. 现在给它过了嘛？但他们要定哪个？两个都用。我两个都用，我把这一做，这个要做。哎呀，这是吧？对，结果的，把这个算那个。大概你的手每天也用。And then follow up with the pipe. Okay, if it doesn't cut it up, that's alright. You just follow the slides later, okay? Okay, so I'll go on. Okay, next, you have to set up the properties of this adapter. Okay, which we use the TCP/IP version 4 right here. Sorry, I'm in Mandarin, but I think you can find this by yourself. So set properties and set the internet. Use the TCP/IP version 4 right here. You can see here's the following up address. You have to help me to set it up. Okay, so we use the IP address with 192.168.1.130 and with the subnet text max. Okay, 255, and 0 like this. And do not press OK. Okay, you have to press advance. Okay, don't press OK because we'll have to add another IP address right now. Okay, so here, after typing the IP, we use advance. Okay, advance. Don't press OK. Press advance. Okay. So when you press advance, okay, you can go to next page. Okay, next page. When you go to advance, you have to add another IP for me. Okay, which is 192.198.140.150. Okay, so why do I need to do these two IP address? Is because one is for the master, one is for master and another is for the slave. Okay, we need to do these two IP in this adapter. Okay, so help me to add another IP right here and so that type it on the content of it, which is 192.19, 168.1.150, and just add the subnet max right here. And press OK, and the setting will be done, okay? So please make sure at this IP setting, you already have 2 address right now. Okay, so that's right. If it doesn't follow up, you just follow the slides, okay? And next, now we'll back to the DIA Designer AX software and try to connect to the virtual PLC. Okay, so first, we'll create a project, and second, we'll create the virtual PLC program, which is we call CODIS Control Wing version 3, okay? So first, okay, I'll back to our okay, we'll back to this DIA Designer AX, okay? And so first, file, I have created a new project right here. Okay, so maybe the name is, doesn't matter. Okay, press OK. Okay, please stop at this page. Okay, at this page is what we want to configure the PLC device. You have to select CODIS Control Wing version 3 x64. This is our virtual PLC device. Okay, so if you are connecting the actual PLC, you will have to select the actual type of this device. Okay, good done. Okay, oh, so I just press OK. Okay. So now they will generate a project right now, like this. Okay. So at the controller, this is CODIS Control Wing version 3, right? And next, go to Windows. Okay, you just type CODIS, CODSYS. You can see here will be a app right here, which is the process of the virtual PLC. So we have to open it up, okay? So just click it. You can see here will be a window right here, and here's a CODIS and stop at here, okay? And after the process is started, you can just minimize the window. Yeah, it's like powering on your actual PLC. It's like this. So if your connection doesn't work, maybe you forgot to open the CODIS PLC program, okay? Application, okay. And next, if your process is started, make sure you already open the CODIS Control Wing version 3, and you just double click the controller here. Controller double click, and here you can press Scan Network and select the computer name right here, and press OK. And if it is done, when you back to this page, you can see here will be a green light for the virtual PLC, means the connection is already established, okay? So that means when you are configuring like DIATwin, DIA Designer AX, like to connecting your actual or virtual PLC, it's the same way, okay? Okay, we still have a lot of work to do, but that's why we're just doing step by step. Okay, and next, okay, we will select the device responsibility in our tools menu, which is like we already export the EDS file, right? So back to this page, we use tool, and here is a device responsibility here. Click. Okay, and press install. and you will find the EDS file that you already saved formally. So export this EDS file, okay, and press open. So after it's done, you can see in this list, there will be a TIN virtual machine in our device list. If we install it properly, you'll find the TIN virtual machine in this list. Okay, please make sure this device is already established. Okay, do it again. Tool device repository install. Okay, select the file, press open, and you will find the device right here. Okay, and after that you can close the window.
I think it's for master. And it's done. Let's get from this. Do it install it yet? You have to install the DIA installer first. Maybe that's what we will test the night later. And can you grab your colleague? And we also have the IO controller. You have the IO controller. Do we have the file? And the IO controller. Yeah, function indicate that.
Okay. Okay, I will maybe wait for 1 minute. Yeah, if you have done this process, maybe you can try on each page is okay, because I already screenshot everything in our slide. Okay. 往下。
Just follow up process first.
Okay, I'll go on now. And next, okay, we'll go to the PLC setting in the controller one. Here's the PLC settings. And what I need to do is to create the enable one.
And in the FTP, we also have already give you the installer of the AX. So maybe you can find it.
Okay, so in PLC setting, we'll set enable one, which is I want to always update the variables when we are communicating. Okay, so we go to PLC, close. Okay, go to PLC settings. So right here, always update variable, we click enable. Okay, and press yes. Okay. PLC settings, enable, and press yes. Okay. So this is for, we want to make the variable always update. Okay, so I'm gonna go to the next step. I think this is quite simple. And next, we are starting to add an adapter for the scanner of this controller. So we'll use right here, right click here, and add device. And you have to select Ethernet IP and select Ethernet right here. Okay, please stop at this page. Maybe you can check out if you add the Ethernet device or not. And when you add it, here will be an Ethernet 1 in the list. Okay.
After you have added the Ethernet,
to create the slave. Okay, so this one is for master, is the EIP scanner. So I press close, go to next page. Okay, we also have to click on Ethernet 1. We have to add another device we call EIP scanner. Okay, so now go to here. Okay, open it up again. Oh, sorry, right click, add device. Okay, and under the EIP, we'll find the Ethernet IP scanner at the directory. In the directory, okay, right here. So just press add device again. So you can see here's another layer right here. Okay, so Ethernet 1, and here's the EIP scanner right here. If you have added properly, okay, the settings right here. Just select and find it under the list. Okay, next, we have to set up the IP address of our master. Okay, so you can use browsing way to select the adapter right here. So like this, in the Ethernet, these settings, Ethernet 1. Okay, I will just turn it on again. Ethernet, general, and you select network interface. I just browsing, and you can find the corresponding address. Okay, 192.198.1.130. So this is the address, IP address of the master, and press OK. Okay, and next we'll click on this one. Okay, adjust operating system settings. Okay, so just press yes. Okay, so browsing, select the interface, and click enable the adjust operating system settings. Okay, so it's right here. Okay, just select it and turn it on. Okay. And next, okay, finally, we already added the TI virtual machine, right? So we also have to add this device as a slave. So, sorry, not this page. So also again, add device again. Okay, you can find a TIN virtual machine right here. So that is created from the EDS file. Okay, so just added device. Okay, so you can see here will be a 3-layer structure right here. Okay, and next, there will be a little complex, but you can see you can follow up with the settings. So first of all, we have to set up the IP address of the slave. So like this, we will set 192.198.1.150 for the slave IP. So right here. So at the slave, double click. Okay, here the tab is TIAM virtual machine 1. Okay, 198 and 0.1.150. Okay, and we disable the checking. Okay, we don't need to use this checking. So we just disable it. So that is the first step. And next, okay. Okay, I'll later. And next, we use connections and edit connections to set up the connections size. Okay, so we'll switch to connections. Okay, and you can double click it, or you can just use the edit connections. Both ways is okay. And when we scanner the size, we'll set it to 480. 480. Okay, and press OK. Okay, we are almost done. Okay. Okay, connections, edit connection, and set out the size of the scanner. Okay. And finally is we have to first select another or just turn it off is okay, because when you just we need to update the contents of this list. So when you just turn it off and open again, you'll find here will be a Ethernet IO mapping table right here. Okay. Here will be an Ethernet IO mapping table. If you switch it or turn it off and turn it on, yeah, and at the down-hand side, we also have to use always update variables settings right here. So here's right here. Just click enable 1. Okay, here, IO mappings and create enable 1. Okay, and here you can also see the EDS table right here. Okay, so what we are already be constructed is displayed in this one. Okay, in this place. Okay, you can find here. At this page, you can find the EDS table right here. Okay, finally, you can try to start your project. Okay, you can just press login right here, log in. So now you will start your process and press yes. Okay, yes. Okay, so maybe there will be some errors right here, and mostly this is because the courses, maybe you need to restart it. But that's right. If you have done this, it's okay. Maybe I can reconstruct it again. So maybe I log out. Oh, sorry. Here. After I log in. Oh, sorry, I forgot it. Here. I will press start. Okay, to start the PLC. So I mean, you will start by this page. Okay. So you can see the master is online, but the slave is not online. The slave is not online because we still haven't created a simulation communication settings. There will be another settings I'll describe later. So maybe we can start at this stage first. Okay, so at the DIA designer, I might say everyone have this kind of status. Okay, so it is connected, and the EIP standard is connected, but maybe your DIATwin, your TIM virtual machine is not connected. It's fine. Okay, we'll start by this page.